Hello, welcome back to Blender Sushi LiveNoding. In this episode, we're gonna take a look at the random value generator in Spreadshop. You probably have seen this many times. There's a random number generator, but if you notice recently, there's actually this option called weighted, and also there's a option like if you go to float, there's option like uniform. So that's kind of interesting, right? There's a lot of new options there. What are they? So let's take a look very quickly. So this is a random exploration. I'm using Blender 2.79, by the way. So Spreadshop is already working on 2.8, but still kind of alpha. So in order to do this, the easiest way is to use maybe a plane and then a B-mesh output. So the plane, this is a plane geometry nodes, and we're gonna just create maybe 10 by 10, so 100 points plane, and then we want to center it. And then I will be using a modifier, displace modifier, so displace. And then on top of this, I will be using vertex weight, vertex group weighting. Okay, so this is gonna be pretty interesting. So, and then for the weight, we're gonna be using this random number generator. So, okay, let's just plug this into that guy. And what's gonna happen? Of course, this random number will generate a bunch of numbers between 0 and 1. The size is depending on whatever we specify here. The output is going to be group weight. If we select these objects and then look at the weight paint, we can see the value that's being generated. To be really even clearer, we can play around with the size here. The size, of course, in this case should be 100, but the size should actually match the number of vertices. So list length, get the total number of the vertices. Look at the stethoscope. Okay, we have 100, so plug this into the size. So we are good. So let's say we want to increase this to 400 points, normalize it if you like. We still have the random, exactly we have like 400 values representing this number. Actually, in this case, don't normalize it. Okay, doesn't matter. So we can, yeah, with this weight, if we go up back to the object mode, we can use the vertex group over here, and we can displace. We can even smooth it. So this is a random value. So if you want a smooth result, turn on smooth shade, calculate normal, and what else you can play around with. Oh, we're gonna play around with the random number anyway. So if we use integer, so this is of course gonna give a value between 0 and 10, but in this in our case, maybe we want between 0 and 1. So if you look at the stethoscope, the result will be 1 and 0. That's the value, 1 and 0, but we have smoothed it, otherwise we have this result. So that's interesting, right? It's looking kind of organic, even though this is a random value as a weight that we are using. We can use weighted. The weighted, of course, you can further adjust the weighting, maybe using noise or even using another random, I think. So this weight is slightly mysterious. Maybe I need to look at the documentations, but you basically can control the distribution of 0 and 1 a little bit better. Normally I just make this number a little bit higher or lower, but for now let's look at the float and then check out the result. Okay, floating value. This is starting to look a little bit like noise, even though it's more like a random number, right? We can try one by one. Beta, so beta, there's this options. There's this option for low and high, so that's also interesting. Binomial, low, high, alpha, they're all kind of similar. I think they're all kind of like a different math algorithm to generate random. What's cool about this, of course, instead of just using plain, you can hold shift, and then here you can use Suzanne or others, you know, like maybe try box. So now we have our box, distribute, like make more divisions and then change the size. So now the noise is being applied to the box and then being pushed through the normal, but with the weighting from Sverchok. Right, so yeah, this is like 20 by 20, so this is like 8,000 points being modified. Maybe make this smaller, 10 by 10, so 1,000 points. Binomial chi-square, what does this look? So it's probably not so obvious exactly, but still kind of interesting. Maybe the weight, if you select this object and go to weight pane, this is a little bit clearer because we can see the how the numbers being distributed. That's kind of cool, I think. Chi-square, exponential. So you can try all of this one by one. I'm just gonna go through it very quickly anyway. This one, F distribution, seems the value is pretty sensitive. They are all kind of similar because it's just random. Laplacian, let me try this one. So 0 and 1. So this looks like, again, something that's kind of organic looking. Laplace, logistic, there's log. Log series. Probably can animate this. Negative binomial. They are all kind of similar. Once again, normal. What is normal? Pareto, what is this? Probably looking at it on a 3D object is not so obvious. If it's like a graph, maybe it's easier to understand actually. With a graph, you want to have, instead of plain box or all this fancy stuff, maybe just use a line. I'm gonna save this anyway and then save again. Save as. So line and edges. So 20, and this line should be, I want to push this line. So with line we have a value, right? So we can just modify the line itself. We don't need this fancy stuff. So line, and we can separate the vector out. So vector out and vector in. So this is going to be the x, and the z is going to be the up and down, controlled by this value. The output is going to be polyline viewer. Okay, there we go. Maybe this is easier to understand. We can then control this value. So beta. So this is random, but it's almost random, but it's kind of like noise. So you can see all this value. Quite nice actually to be able to see this and visualize the numbers. I don't know how, maybe you have some kind of data and then the data is random, but you can look at it and then, okay, you can kind of look at it. Okay, this is kind of similar to this kind of random algorithm. So you can use that algorithm on your research, whatever. I'm just kind of guessing. So yeah, that's kind of nice, right? Yeah, if you like, random is nice, of course, and our main actor here is the random, but of course we have also noise and turbulence. Don't forget about that. Turbulence, you can just plug in this guy and use the scalar number and use it on the Z. So with this, of course, you can move it. Just move the line, and with the noise you can control it. You can animate it easier like that. So this also have the typical foro noise, cell noise, those sort of stuff. Yeah, I think they're really cool. So yeah, this is how you can look at the random number. Now you know there's a lot of options with random number nodes, and how you can use it to visual, and you can visualize it as a line graph like this, or as a 3D objects. So yeah, in this case we actually made two different node tree. One is using line, the other one using box and plane. But play around. Random number, vector turbulence, and vector noise, they're kind of like a siblings. They produce and generate values based on whatever input you put it in. In this case, of course, it's always either vertices, but the output is going to be vector or scalar, a single value, or multiple value, but a scalar. Anyway, that's pretty much it for this. Let me know what you think, and I'll see you next time. Thank you. Bye.